Hi guys, welcome to Learning Electronics Repair. This has been sitting here for a while. It's a pergola controller, so this is for like a sliding pergola at a house, bioclimatic, remote controlled thing. And often these things sit around because these villas and places are not occupied all year round, but they need to get this one ready. So I have some parts here, I had to wait. Originally, I ordered the part that fits here, very small MOSFET. I'm going to show it to you. And after I fitted it, it was short circuit again. So I think this is probably, I was trying to do this by putting solder on, using hot air, placing the thing in, getting it hot. And I think I actually killed it, you know. This happens. So I then ordered some more of these little MOSFETs, only to find that I didn't actually have the big ones. So it's like one of them, yeah, but everything's here now, kind of. So let's see if we can actually fix this. And the first thing is, let's see if we can actually solder the thing onto here without damaging it again, okay? So this time I actually ordered two of these. I only need one. One of them is here. This is like a heat sink pad type thing, but it just keeps this thing still because it's so small. Yeah, this is tiny. It's about 5mm square, something like that. Okay, you can see the part number, by the way, of this one. I'll show you. And then we're going to test this. We're going to test the PCB, and we're going to try and solder it and see if it all goes okay. So the port is 086P3NE. I just checked one of these, by the way. They are just over 3mm square. Yeah. Let's just look at the datasheet of that. So this thing is a P-channel MOSFET. 4 pins are drain, 3 are source. We can see the gate. We can see the parasitic diode in there. Let's check it first, and then let's check the board again to make sure there's no shorts, and then let's try and fit this. Now you see why I need the little pad or something to stick it down. A bit of blue tack, of course, would do this as well. Okay, so P channel. This is the drain, all 4. I'm sure these 3 are the source. They should be connected to each other. These ones. Yeah, so that's the gate. So if we go between drain and source in this direction, parasitic diode. Okay, so black on the gate to switch it on, and it was then switched on for a moment before it went off again. Okay, fine. So on again. Yeah, that time it stayed on. You can see the climbing up. Okay, so I'm happy the port's fine. I've put a bit of flux on here already, but we can still just check. So this is where it goes. So there's no short there. Drain to source, source to drain. Okay, so there's no short. We can see the gate is there, goes that way. There's one fitted as well. We can see one over there. Yeah, parasitic diode there. So obviously we don't see the parasitic diode here because it isn't fitted yet. So I need to get this little thing and get it soldered in there. And I tried this a week or two ago. I wasn't actually going to make a video of just fitting the parts, and when I fitted it I had a short. I either had a defective part or I killed it by getting it too hot. I only ordered one, which is something I really don't do, so now I've ordered 2 of them. Let's see if we can replace this. So the first thing I'm going to do is add a bit of leaded solder. But I don't want to get too much, so it'll sit fairly flat. Yeah, I just want a bit. There, probably a bit too much actually for my liking. But I do need to have some on there. Okay. Yeah, I think that's better. Right. Now last time, as I say, I tried to heat this up with hot air and stick the thing on and then keep heating it up. So I thought it was stuck down and then it was short. So I'm going to use the preheater this time and see if that helps at all. Yeah, a bit more flux. Possibly a touch more solder as well. Let's see. I think we will go with that, you know. Let's see what happens here. At least there's something for the thing to stick to now. So here is the part. I'm just going to orient this the right way round, ready? Yeah. Let's just practice this a little bit. Okay. I'm hitting the aerial, so I'm actually going to just unplug that. Go again, try this. Well, first of all, this is moving. That's not a good start. Okay, the thing's moving, so I need to clamp it so it can't move. And the second thing, I'm going to have to come in from the other side, from my right hand. Okay, I think I'll also try to get a little bit of solder on this as well. I mean, not much, yeah. Let's see. Okay. So the idea is to effectively melt the solder and then just drop this in place. And hope that the surface tension will pull it into position. Right. Time to warm it up. You don't want to do this too quickly. You want to get plenty of heat evenly distributed around here. I'm really hoping that I'll be able to easily melt the leaded solder before the lead-free solder melts. So first of all, let's see how warm we can get this with the preheater. Okay, so I can only get it up to about 90 degrees now. Although actually, that looks like it's melted. Maybe, in fact, that's just not giving me an accurate reading at all. Let's come in with the component. And I think that pulled into place. Okay, so shut it off, let it cool down, and let's see what we get. Well, I'm sure we can see that was not successful. It's offset to one side by the looks of it. This is a lot of flux in here, so you can see it's all soft. So let's clean that up and let's have a good look at what went wrong. Well, it's on the right way round. This is the other one I have. Okay, this is our other chance at getting this right. So you can see that the 4 pins are all connected together. A bit on the end that actually has the writing there. Okay. Yeah, so it's definitely on the right way round. It's just offset, just very slightly, but obviously it's not making connection to the pins. You can check for shorts. So from here to here, no short there. So we haven't caused a short, but I think we'll find we don't actually have connection to the... Oh. Actually, it looks like we do have connection to the MOSFET. Yeah, what about the gate? That would suggest to me that is in actual fact soldered, but I don't like it. So I'm going to warm this up again with the hot plate and just try to center that up a little bit. Is this the point at which we should have just left it well alone? Well, let's find out, yeah? Okay, I've had to put it this way around because I'm right-handed. I need to get in here with this side, which is a bit of a problem because I can't now see the pins on the MOSFET, which is what I would like to see. But if I arrange it so that I can see them, then I have to do it left-handed. I don't trust my left hand so much, so this way it's going to have to be. Okay. I'm going to use my other thermocouple and temperature meter. The other one didn't seem to read very well at all. It may be a problem with that thermocouple. It may just be that I can't get it into the best position to read the temperature accurately. So we can try with this one and see whether or not it actually is better. So power on again and let's warm it up. I'm not totally sure this will work because we may just actually, you know, cause a short, cause solder bridge by doing this. But we are going to try in the interest of science, yeah, and entertainment. Let's get the temperature up. It's clear that we can actually get the solder to melt, even though the temperature would indicate that isn't the case, or at least it did before. Yeah, it's reading higher now. Okay, we're getting towards about 3/4 now on the dial. Let's change it up to maximum now, see if we can get this to unsolder, and then we'll move it a little bit. Not yet. Still not yet. Okay. Nope. Nope. $180 odd it says. Yes. There. I'm not going to try and straighten the other end. I'm going to leave that. Switch the heater off. Let it cool down. Well, it looks better, I will say. There's something black on there. Here. Something sticky. So let's clean this up again with some isopropyl and we can have a look to see what we have. Again, we can test with a multimeter. So I'm just touching the pad, have a connection. Obviously it's not shorted to the gate, and the gate, again I have a connection, and from the source to the drain there's no short. So that is connected, it's just slightly, well, you can see it. Let's just try now, because I'm a bit, you know, guys, with this one, am I going to make it worse? Yeah. Am I going to make it better? What I really need to do, I guess, is to kind of like just gently push down on this side. Let's get the soldering iron. Okay. Does that look better? Yes, it actually does. Well, there's no shorts between the pins. I just can't be totally convinced that that drain is connected. Definitely not shorted. You know what, guys? I'm going to have to straighten that again. Okay. While that's just cooling down a moment, this is the preheater I'm using. So Corda 853B, just a manual control. The temperature doesn't really mean anything particularly. So that's why I use the thermocouple to see what I have in the way of temperature. 2 switches, heater on off and fan on off. So you can switch the heater off and leave the fan on to cool as well. And that's basically it. These things, 35, 40 euros. Maybe they've gone up a bit like everything, but I paid something like that for it. And it's a really handy bit of kit, this, guys. Hope you'll agree with that. Okay, look at that. Yeah, it looks good now. Let's just make sure there wasn't enough solder underneath to short anything. I don't think, but we're going to find out right now. So, do we have a short? No. Other way, do we see a parasitic diode? Yes. So that's good. Let's go to the gate, which is here. No short, no short. So that one now is soldered, guys. That took me 3 attempts. I've never tried to solder one of these things before, I'll be honest with you. So I'm hoping that shows that really the only way to do this is to do it. Yeah. And I did this on camera in front of all you guys. If I could do that on camera in front of you guys, given all the things that could go wrong, and they did twice, but you know, analysed it, worked it out, and now I have it right. And when I come to do another one of these, I'll have it much easier, I think. Okay, I've cleaned the flux off so we can have one final look under the microscope. That actually looks professional now, guys. I hope you agree with me. I'm really happy with the way that's fitted. A little bit of a blob at the back, but you know what, that's nothing to worry about at all. That looks nice. So the next thing we need to do is fit the diode back on. This goes here. You can see effectively it's just a diode or 2 in parallel at the most, so these pads are connected together. And here it is. This got removed not because it was faulty, but while I was trying to find where the short was. So I had to remove a couple of components to see where the short actually was. I could solder this the same way, but I'm quite happy to solder this using a soldering iron, I would think. Let's just see. We can always change our mind, of course. So we can get this pad hot. Okay. Just drop our diode in place like so. Push down on it a little bit. I can get enough heating from this end to do this. Okay. There. No problem. So this is a fairly easy component to solder actually. Okay. There you go. We can now check this, so not that way. This way. Reading a bit lower now, you'll notice that's because it's hot, so as it cools down, you can see it happening. The value is increasing a little bit. Now the MOSFET. Now this is going to be a bit of fun because I mistakenly ordered the wrong kind. It's the right component, VNB114NVD, okay, but it's physically too large, so I'll show you the original one from the other side. There, that's one of the original ones. 14VND NV. So the NV and ND is a different package basically. So you would think 2 things: 1, we could use any old MOSFET, and 2, that I couldn't fit the other one, but neither of those are actually correct. So this is the MOSFET OmniFET 2 fully auto protected power MOSFET. It has linear current limitation, thermal shutdown, short circuit protection, integrated clamp, low current draw, blah de blah de blah. And you can see inside this we have the input, which is what you would call the gate. Then there's a gate control controlling the gate. There's an over voltage clamp. There's a linear current limiter. There's an over temperature. This is a constant current source or reference. So there's a lot going on inside here other than just a normal MOSFET, which means I have to use the correct type. I thought I ordered the correct type and I actually didn't. But it's close enough. So that's one of the original ones. Okay. And here is my replacement one. And it will fit. This will fit into there. You can see it doesn't solder to these pads here anyway. If you look at the other ones, they don't solder to there. That's where I removed the other one from. And the reason I removed this, not suspected to be faulty, it was because I wanted to, having removed this one, I wanted to remove that one, so these circuits were identical to each other, so I could trace the short more easily. Okay, so that's why I took that off. So this can go back on where it came from, I think, and I'll solder the other one here. I'm just gonna trim these legs just slightly shorter. Okay. Yep, that's better. Right. This, I think I need to add a little bit of solder to this. Okay. Same on here. Okay. Get us nice and hot. You could also preheat the whole thing with a bit of hot air as well, of course. Yeah, this one I think I'll use a bit of hot air actually. It's also offset anyway. Now everything's all young. because I was hitting this pad, all these melted and moved a little bit. I had to just reposition them slightly, but they're back on okay. We can compare this now with one of the other channels to make sure everything reads okay. So this is the diode we can see on the other one. Positive here reads 2.3. Diode junction, okay. Same with this one. Obviously it's the other physically way around. 2.3, it's gone up now. Diode junction. Then source, drain, again climbing up. And that reads like a parasitic diode, like a normal MOSFET, okay. This one, parasitic diode, very similar value. Reads open, okay. To the gate, reads 1.4. 1.4 the same, and then this is our other little component, so reads like a diode there with the black to here, same, okay. And then the gate just reads like open, 2.09 with the black on the gate. So on this one the gate is here, 2.08, and this reads also like a parasitic diode. Yeah, value going basically to the same. So they all read the same, both channels. I'm happy, that is just fine. That's as much I can do with this because it has to go onto the equipment. So I'll let the guy have this back and then I'll let you guys know what happened next, okay? One thing I will just mention, by the way, because this was all burnt out previously, I am going to ask him to test the resistance of the motor windings, yeah, because there's two. They connect here, you can see where they actually go to it. So output VDC, and this is probably a sensor plus or minus, yeah. This will be the up and down or back to front signals, I would think, to move it either way. So on the output, he needs to measure the resistance on both motors to make sure that this one isn't short. Okay, hope you enjoyed that. A little bit of a challenge, that one, I think. It shows you can work on this stuff. A bit of practice is involved. I really should have figured out what was going to happen with this and not got this hot enough for these to move again. But this time I actually got away with it, okay? And it all looks fine. Okay guys, epilogue time. So good news on this one. The engineers took the PCB from me a few days ago. They fitted it. And I have a message back to say it worked perfectly. So here we see it. Good afternoon, Richard. It worked perfectly. Please send us an invoice when you can. Thank you very much, Sarah from Domus. I've shown you guys the company website before on some videos. So Pergola controller. So this is the one without any personal details disclosed, if you like. And they're very happy. So I will build them for that one. And it's all happy days. Okay, so hope you enjoyed that. A little bit of dodgy soldering maybe, but you know, I don't do that sort of work so often, as you guys can see, but I managed it and now you guys know what not to do, yeah, and what to do. Okay, hope you enjoyed that. I look forward to seeing you all soon again on Learn Electronics Repair. Ciao for now, guys.